I have a map open here. I'm just going to close my data manager, and you'll notice here on the left-hand side there's an additional pane. For the GIS user, you may not be used to seeing this. This is called the Scenario Manager because it includes this Scenarios section that provides a hierarchical list of all the different alternatives we might test using this model. And then below that we have a data pane that gives us a set of sort of virtual folders for organizing the various data inputs and outputs that are related to the applications or models we might run for these different alternative evaluation cases. So right now I have the inputs section of this data pane expanded, and then within that the maps section I'm viewing the land use update map, and I might double click here on this screen line counts map, which is the last map that Keith created, and I can review here that yes, we have new count information entered into our network, and the screen line locations are all highlighted appropriately. So with this in mind, I'm ready now to go ahead and launch a scenario run. So I'll close this map window, close both the map windows in fact, and double click, or rather I'll expand the base scenario and view some of the hypothetical alternatives I've kicked off underneath this. So we have a land use scenario here, and double clicking on that opens up my scenario editing window. And as you can see, this scenario uses the no-build network. In other words, we're not adding in any new highway projects yet, and it uses the base system of public transport services. All we're changing is the demographic assumptions. And bear in mind, these are simply assumptions. They are not generated by a land use model yet, although we do have that capability with the new product called CubeLand that can be integrated with your travel model for forecasting land use into the future. But right now, we're just working with calibrating our base year data, making sure that we have the latest planning assumptions from Keith and the GIS team. And so I'm going to kick off a run of this land use scenario. And it's going to open up this environment called the Task Monitor, which tracks the progress of the model run. This model run will only take about 1.5 minutes because it's a very small little demonstration model, only 25 zones and a handful of links. And in the background, I'm going to open up the application view so that we can see what is actually being run. So what we have here is a typical trip-based travel demand forecasting model with the standard 4 steps called trip generation, trip distribution, mode choice, and assignment, as well as pre-processing and post-processing steps that read the data in from the geodatabase, convert the highway network and the public transport system definitions into our internal efficient proprietary formats, the transit line file and the binary network file. And we use these formats within a feedback loop which iterates through trip generation, distribution, mode choice, and assignment until we have reached full system convergence or equilibrium. And then at the end we have our final version of our equilibrium highway assignment, giving traffic volumes on our roadways, and we convert that back out into the geodatabase using the geodatabase output processing step. So each of these boxes here is a step in an overall process. The blue boxes on the left-hand side are basically input files or data sets. The green boxes are output data sets or files. And in fact, each of these is not just a single step. Within them, there's more detail. So if we double-click on, for example, GDB output, we see there's actually several steps here converting data from our proprietary native formats into ESRI-compliant geodatabase formats. So what we've done here is we've taken all the conversion work, the conversion programs Keith mentioned, and we've embedded them into the Voyager model. So the Voyager model is actually running directly from the geodatabase, and we don't need any external or manually run third-party programs to view the outputs. So my run is complete. Now I can go ahead and use Cube's built-in reporting functionality. If I go to Data Reports, I can take a look at some standard template reports that I've set up for all of my various outputs. And the one I'm going to look at here is the Highway Assignment Report. So this Highway Assignment Report tabulates some information, some tables based upon key variables such as roadway type, number of lanes, congested speed, volume to capacity ratio, indicators of congestion on the network under this scenario. And I also can look at scatter plots of counts versus assignment. It'll give me some idea of where I might need to improve my validation, possibly make some tweaks to the network, check the accuracy of my input data, which of course would be a task I would engage in collaboratively with Keith. So that would be an example of using the GIS data then to get a better sense of what's going on in the model. I also want to mention that the outputs, again, are all Voyager outputs that are stored in the geodatabase. So if I'd like to take a look at, for example, intersection level of service in my output model, I can open that up, and I have a map all set up that really quickly shows me where the problem intersections are in the network. And quickly we can see that this east-west congestion is creating a lot of congested intersections in downtown and nearby. We can also set up bandwidth plots if we want to and look at where this congestion might be located. So we have a lot of congestion in this east-west corridor. And the next thing we're going to do is probably save a map document containing that information, give it to Keith so that he can actually take it to a planning manager who's going to take it to the city council meeting downtown, present it to the public, present it to other stakeholders, and find out what possible solutions we might want to analyze for improving congestion under these anticipated or actually existing conditions. So with that, I'm going to give the presentation back to Keith, and he's going to show us the next demonstration.
Many thanks, Colby. So hopefully that gave the GIS folks out there a good idea of what the cube modeling platform is all about, giving you the convenience of using Scenario Manager and different types of things. So the second thing we were going to look at was an integrated workflow for scenario analysis. So in this case, we're actually going to run new model scenarios instead of dealing with the base year calibration. So let's suppose that due to the growth we've had on the eastern side of the city and the employment growth in the downtown, we've had significant congestion build on the east-west corridors. Our planning manager would go out to the stakeholders, who's probably the city council and other members of the public, to talk about these issues. He would then come back to the modeling team and ask them for new scenario runs. Now in this case, it's very simple. The modeler probably could have coded up the database themselves, but for the example, I'm going to go ahead and code up the networks. Colby's asked me to make changes to a build scenario and a transit scenario. So our build case is really very simple. Years ago, a bridge was falling apart, so this road had to be closed in 2 locations, leaving a gap in the network and the inability for folks to travel from east to west along this corridor. The city council proposed that maybe this bridge should finally be replaced, and it would alleviate some of the traffic along the corridor to the south. So I'm going to go ahead and use Sugar Editor to make that change to the data set. You'll notice I have the different scenarios in here. This one, in this case, it's called the build scenario. I went ahead and added that to my table of contents. I can then go ahead and start an editing session. Close my data manager, and now you're going to get a look at the Feature Explorer. So the Feature Explorer is what really helps me make network edits to this network. Using this toolbar, I can select the Modify feature or create new ones. So in this case, I'm selecting this adjacent link here to see what some of the attributes are. You'll notice the Feature Explorer is showing the line directionality conveniently. It's also showing the node topology. It is nice to actually post your nodes so you can visualize that topology in the map. Very easy to do with ArcMap. Just posting that end field. Well, so you'll see that those 2 nodes are reflected in the Feature Explorer window. You can also see that I have a series of attributes and data values associated with this link. Instead of recreating them for additional links, I can choose to copy those attributes. Now, when I go to make edits, those attributes will automatically be carried forward into any new links that I add. If I unselect this Apply Feature Templates to New Features button, I'll be back to editing a baseline network without any attributes associated with it. But for this case, I really want to select that feature, copy the attributes, and then I'll go ahead and create a new feature to exemplify this. So you notice now I have my new feature selected. It's showing me the node connectivity and giving me an indication of the same exact values that were on the other one, with one exception. The distances were updated, allowing the network to understand how the time distance required to traverse that link. With that scenario ready to go, I'll go ahead and save my work. Now this was a simple case, but you can imagine having hundreds of edits and that kind of thing where the modeler may not want to focus all their attention on that. And a GIS person can really help make those modifications. So I'm going to go ahead now and take a look at the transit lines. Now the other alternative that our city council proposed was maybe increasing the transit. They didn't want to simply have a highway widening project. They thought that more people should consider transit, especially if they're living in these outlying areas. So I'm going to go ahead and add a new scenario to my table of contents called the head weight. Now we're going to use Sugar's public transit editing module to show how edits are made to the transit network. I'm going to go ahead and remove this build scenario to make my view more clear. With the transit data added in, you can see my transit lines indicated on the map. If I turn off the intersection data, that should be more clear. Now to make these transit changes, I contacted our local transit service and asked them for a new proposed route. What would make sense for this area? I'm not a transit expert, but I certainly know how to manage data that I can get from them. So I'm going to go ahead and add this new transit service to my map view. And I'm going to render it so I can visualize it a little better. So you see a new transit line heading into the downtown. I'm going to go ahead and start an editing session, click on the database that I'm going to modify, and hit OK. So the first thing you'll notice is that my transit editing tools are enabled because Sugar knows that I have a transit layer inside my database. Now I'm just going to trace along this line. What's important to realize is that it's going to be following and maintaining the network integrity with the highway network. So these two, the transit line file and the highway network, are synced together. I'll hit my new public transit line tool, go ahead and select the first starting node, and you'll notice the attributes are automatically brought up. I can click from node to node. Actually, let me zoom in here a little bit so we can better see this. So I can click moving this line from node to node, or I can skip nodes, and it will follow the shortest path algorithm that it uses for coding. This makes transit line editing very easy with Sugar. So I'm going to go ahead and finish that line. I need to assign it a name. In this case, I'll call it the dash, and we'll give it a mode 1. And then I'll validate that link using this checkbox. It's now validated my link and committed the edit to the database. By saving the database, my edits are now complete. The other change I'd like to make to this network is an improvement in the headways. So I'm going to go ahead and select the flash line, and I'm going to make this service more frequent by cutting these the time in between buses in half. So in that case, I'm going to put a headway of 10. This is another time of day service here, so I'll change those, and I'll set this to 30. So this is going to significantly improve transit service heading east-west here and to the south. And I can go ahead and save those edits to the database. So in that demo, I just showed you network editing, some of the basic tools. There's a lot more included in Sugar, including junction editing, which I'm not going into. But please feel free to go to our website and look at the other webinar to learn more about the junction editor, feature editor, and some of the options available in Sugar. With those changes made to the shared database that Colby and I are using, I can turn the presentation back over to Colby. He can bring those scenarios into Cube and run them to test how these improvements in the transportation infrastructure have changed the network.